All right, you guys. I think I have some good news. Today is the last. I think the last kind of new material. It's not really new. It's just an extension of what we've already talked about, like these exceptions that are kind of commonplace, but we'll practice. And so that's it. And then after this, it's just practice, 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 practice. We might do some small group stuff one day, or we might do some. Um, I think it's important to try to practice, practice. I know that sounds like weird, but how do you find new examples? How do you? So we might even have like a day where we just kind of practice, how to study. Because if all you ever do is look over the same ones we do, I'm never going to ask the exact same questions. I might use the same pictures, but I'll always try to deviate it a little bit, not to be tricky, but to check your understanding. That's what it's about, right? Um, a cliche that I've heard several times is that I didn't really learn a lot in college. I really started to learn exponentially when I started working. And that's because you have to apply stuff. Like you have to start figuring things out. And so I'm trying to introduce you guys to that skill. It's just like any other skill. We can develop it. We could get better at it. And that's what I feel my job is to kind of prepare you for some of that figuring-y, outery things that you're going to have to do in life. Also today, I got an email question. And because of my dyslexia, it's really hard for me to communicate a big, long answer. So I'm going to do it in class. I'm going to answer that question in class so that, and then that way. So if you have any questions like that, that's how I'm going to do it for them. All right. A couple quick notes. So we talked about the work equation being our inspiration for muscles influence motion through contraction. It's literally the work equation that we're just looking at specifically how internal muscles influence external. So this concept, its motivation, its inspiration is F is equal to ma, high school physics stuff. A little nuance to this equation, though, is it's not just any force that's going to cause something to accelerate, because, I'm applying a force to the ground. It's not moving. It's not going anywhere. It's applying a force up to me. I'm not accelerating. So it's important to know that it's the sum of the forces. We've been talking about this for a while. We just haven't put a fancy term on it, but it's external forces versus internal, the tug of war, right, between external and internal. That's what that means. It's the sum. It's after we balance our checkbook, whatever is left over is what's going to accelerate. Meaning, if I have $1,000 in my checking account, and during the month I make money and I spend money, so those transactions, there was forces that was trying to change my balance. But if the sum of all of those forces canceled out, then I didn't have a change to my balance. My balance stayed static. It's kind of like that with forces. You have different forces, but if those forces cancel out, there's no change. There's no acceleration. If I spent more than I took in, there's going to be an acceleration to my balance. And if I take more in than I spend, there's going to be an acceleration to my balance. It's the same thing with forces. Something has to be greater than something else in order to speed something up or slow something down. Okay? So acceleration for this class, we're just going to use speeding up and slowing down, because if something is getting faster or getting slower, it is accelerating. It's changing speeds. Cruise control is constant. You're not accelerating. So in these examples, it's important to just understand, I'm talking about speeding things up and slowing things down specifically that won't have gravity or won't have external forces influencing it for these first few examples. And so, example, if I start here and you say, well, gravity's trying to adduct me, you're absolutely right. But gravity is not trying to horizontally adduct me. So some force had to be there in order to speed up my horizontal adduction. And if it's not external, it's got to be internal. It's got to be our muscles. And muscles can only pull. So I couldn't use my horizontal adductors to push me across, right? It makes sense that in this example, I would need horizontal adductors to pull me across, to make me speed up. Make sense? Now, the same thing that pulled me to speed up can't push me to slow down. It's kind of a variation of our jumping jack example. So when it comes time to putting on the brake and there's no external forces to do it, I have to turn these muscles off and turn on their antagonist. The antagonist to the horizontal adductors have become the agonist when it comes to braking, when it comes to slowing down. So these examples are going to be what sped me up and how, agonist and contraction, and what slowed me down and how, agonist and contraction, without the presence of an external force. So without the presence of external forces, it should make sense that concentrics is going to speed you up, because that's how muscles influence motion, is by pulling. And eccentrics is going to be the brake, so it's going to slow me down. When was the last time, or has anybody ever taken their vehicle into the shop, and you don't ever go take your car in to get the gas fixed. You got to get your brakes fixed, like the brake pads. So in other words, braking seems to cause a heck of a lot more cumulative damage than gassing. Kind of makes sense. I think we hinted at this with ropes, right? Ropes fray because they're being pulled apart, not because they're shortening. It's when a rubber band pops, not when it's shortening. It's when it's being lengthened. That's when something's going to pop. So it's no different. The eccentric slowing down is important for us to identify, because that's when the micro frays are going to happen inside the muscle. That's when the macro frays might happen, a pull or a rupture. So it's important for us to see braking in muscles, slowing down because of eccentrics. Let's do this first example. External force is trying to do this, but you observed this. We have to know what that motion is, right? We spent 2 months on this. So there was horizontal adduction is what you saw. We also have to assume that that motion had to speed up and it had to slow down. What goes up must come down. What speeds up must slow down. Because our joints can't just keep spinning in the same direction forever, like the earth. So the motion we had was horizontal adduction. There was no external force trying to make me do this. So that right away should be, my muscles had to be responsible for all of that stuff. Concentrics is going to speed up my motion. Eccentrics is going to slow down my motion. That's important, that it can't be the same muscles. It should be common sense, but sometimes common sense flies right over my head. So that's why I use things like the same muscles that pulled me across can't push me to a stop. So what was the agonist that sped up my horizontal adduction? The horizontal adductors. I'm going to teach you who those muscles are, but we have to be able to visualize that muscles that pull across, have muscles that pull in every direction of motion that we have. Why don't I just say pecs? Because it's not just the pecs. The pecs are part of a team, they're part of a group. And if all we ever do is say pecs, then we lose or we forget the other muscles, and those other muscles may have problems with them that you may need to fix one day. Horizontal adductors working concentrically is going to speed up my horizontal adduction. But the same muscles that pulled me across can't push me to a stop, and this braking happened pretty quick. Meaning it didn't gradually come to a stop. Like you would take your foot off of the gas and then your car would gradually go to a stop. You're driving and you're pushing on the gas pedal and you're speeding up. And all of a sudden that darn light turns yellow and you're like, you got to slam on the brakes or put on the brakes aggressively. You're going to come to a stop in a small amount of time. The only way that's possible with no external forces is for me to turn off the gas muscles concentrically, turn them off, and turn on the braking muscles. So the horizontal abduction pullers are going to slow down horizontal adduction, eccentric. So it still fits our equation. It still fits our sentence. Make sense? Now, if I wanted to do more, in other words, if I wanted to speed up and slow down only, horizontal adductors concentric sped me up, horizontal abductors eccentric slowed me down. But if I wanted to keep going, I could do that. Concentric speed up, eccentric slow down, concentric speed up, eccentric slow down, that's our plyometric sequences. So just going to flip-flop back and forth. Make sense? Okay. Let's do one, Grace. Before I give this next example for them to practice on, do you have any context or feedback on these?
I feel like, yeah, with the plyometric, or with things moving faster than gravity or an external force, like, yeah, it should be an automatic, like, constant.
Absolutely.
Like, no doubt.
Because that's the only option, right? Like we can't use Harry Potter magic, and muscles can only pull. So we have to get over here. It was back in the day, Street Fighter. All right, let's do a couple practices. And I want you to do these on your own, and then obviously we'll discuss them. Let's say, because you're probably like, dude, when are we ever going to do this? Fair enough. But what we can do very often is, let's say something gets your attention to your right or to your left. In this case, it's going to be to my right. So I want you to keep it to your right. So in other words, if I look to my right, I'm going to look at that wall. If you look to your right, you're going to look at that wall. It's okay. I'll just do this. We'll all look at the same wall. But let's say something gets your attention and you look really quick. Again, our braking muscles prevent us to getting to the end of our road where ligaments may, like you don't want to twist your head as fast as you can all the way at the end of your range of motion. That even sounds like, so we use muscles to help slow us down at the end of these ranges of motion. So let's look to the right as fast as we can. Note the motion. And then the logic of whether gravity's not trying to make me look to the right or to the left. To Grace's point, that should right away infer I need muscles to help speed me up and slow me down. And in an absence of knowing what those specific muscles are, that's okay. Just know you have to have muscles that pull this way rotationally and that way rotationally. And then we'll talk about who they are once we get a grasp of how they work. Okay? So here's your two questions. Look to the right as fast as you can. Don't go all the way to the end of your range of motion. I need to know the agonist that sped up my right transverse cervical rotation and the contractions they use. And then the agonist that would have slowed down my right transverse cervical rotation and the contraction they used. Fair? What sped me up? What slowed me down? Go. Do a pelvic curve. So we'll do a few of these practices. Then I'll answer the question that I got on email about pelvic girdle rotation example that we did in class. And then I'm open to, if there's questions, conversations, things that you want to fine tune, I'm welcome to that at the end of class as well. Also, while you're thinking, I'm going to distract you. It's like practicing in the rain, make you better when it's not raining. So our test is on a Wednesday, the last Wednesday of class. Friday is kind of an optional, if you want to prep for your optional final, if you want to make sure you have the grade you want before you choose, like that's what the Friday is going to be. So in other words, I have a B, I want to make sure I have a B, and I don't want to take the optional final. That's cool. So Friday is just going to be a day where we can just make sure we're all on the same page for the finals week. All right. Nothing's trying to make me look to the right, so I have to make myself look to the right. We're going to use muscles because muscles can only pull. So the inference is going to be if I have right transverse cervical rotation and I went from not moving to moving, everything has to speed up. I mean, think about it. You go from zero motion to any magnitude of motion, zero to whatever, there has to be an acceleration. There has to be a speed up part. We may not see it because our eyes can't process fast motion. It looks like it happened instantaneously, but nothing can go at a red light. Even though you punch the gas, nothing can go from 0 to 50 miles an hour unless it's sped up to it. Okay. So I had to speed up. I'm going to use right transverse cervical rotators to concentric contraction because I can't push from the other side. I have to pull. I'm going to teach you who those muscles are, the left sternocleidomastoid, the right erector spinae working as a force cup. We're going to go through all that stuff. But if all I did in class was teach you about sternocleidomastoids, it's really hard because those muscles are named after origins and insertions, not motion pull. And that's the key. If we can understand how muscles influence motion based off of pulling, it really helps us to see these muscles easier when we talk. Okay. So right transverse cervical rotators concentrically, speeding up my right transverse cervical rotation. The same muscles that sped me up can't push me to a stop. So I have to turn the right transverse pullers off. And when it comes time to braking or slowing down right transverse cervical rotation, I got to turn on my left transverse pullers. So left transverse cervical rotators, it's like running in the wind. It's like, kind of how it works. An analogy, it's not a practical analogy, but it's real. So in other words, it's not practical. You would never do this. But imagine if you didn't have a brake pedal in your car. So you didn't have that option. If you were rolling forward, you could shift into reverse. That's what I'm trying to insinuate. Shift into reverse. Turn off the forward rollers and turn on the backwards rollers. And that reverse will slow down your motion one way. And if you stay in reverse, it'll speed your motion back the other way. It's very simple. That you're doing this, you're going to turn off the drive and turn on the reverse, and the reverse is going to slow down your motion one way. And if you keep the reverse on, it'll speed your motion back the other way. Again, it's not a literal example, but it's just trying to show you that something pulling another direction has to first slow you down in the opposite before it can speed you up in the direction of pull. I use that example with the car, where once I pull it to me, I'm done until something else slows it down, something else speeds it up. Then I can pull to slow it down going away from me and speed it up coming to me. Okay. Let's do one more example, and we'll use hip muscles of pelvic girdle rotation because of hip muscles. So in this example, I'm standing and I'm going to have right transverse pelvic girdle rotation. And on the test, I might say you're standing. Obviously, there's no external forces trying to make me twist. So right away, I need muscles to make me twist. We still need to remember illusions of motion, because if you don't have the motions right, we can't get the muscles right. Unless it's like a double negative and you missed it twice, so you get it right. Okay. So what if I phrase the question this way? You're standing, anatomical position, and you have left transverse pelvic girdle rotation. So I'm giving you the pelvic motion. And then the follow-up question after I give you that information is, what muscles at the left hip would be responsible for speeding up the left transverse pelvic girdle rotation? I'm going to say it several times just to make sure everybody understands the question. You're standing in anatomical position. I'm telling you, you're going to speed up left transverse pelvic girdle rotation. And I'm specifically asking you to tell me which muscles at the left hip was responsible for speeding up that left transverse pelvic girdle rotation. Does everybody understand the question? This is where you could practice in small groups or get your answer and then check with Grace. Hey, Grace, am I on the right track here? To me, that's how you learn. You learn by missing shots. Go. If anybody needs me to clarify the question, just let me know. I'm specifically asking which muscles of the left hip was responsible for speeding up my left transverse pelvic girdle rotation while I was standing. After we do this example, if there's no questions, then I'll do the pelvic girdle to trunk question that was emailed. Follow-up question. Would the muscles at the right hip be the same muscles or different muscles? Just something to think about that I'll answer after we do the left. Would just yes or no, would the muscles of the right hip be the same or would they be different muscles? On the test, I might do like same muscle, same contraction, same muscles, different contraction, different muscles, same contraction. Like, that's how I ask questions. Right. Agonist at the left hip. Does it make sense we could eliminate flexors and extensors? Because that would be like anterior and posterior stuff. We could eliminate ab and adductors in this example, because that would be right and left laterals. So this is another tool you could use, it's just elimination. Like you may be like, oh my gosh, there's so much stuff the hip could do. But you could eliminate sagittal, we could eliminate frontal, and it's internal or external. So at least it gives you a 50-50 shot. Nothing's trying to internally or externally rotate me. So that means I have to use concentric contraction to make it happen. What motion happens at the left hip when I have left transverse pelvic girdle rotation? Internal, good. So do you see why those motions and those positions are so important? If we don't have the foundations, how are we going to get, ask any chef or baker, like it's the foundational stuff. We see the finished product, but it's the fundamentals. So fundamental to be able to understand muscles and motion and rehab and exercises is these joints and these positions and these motions. Nothing's trying to make me internally rotate my left hip, so I have to use muscles to do that. So I'm going to be using concentric contraction of left hip internal rotators to make the left hip internal rotation happen, thus helping to spin my pelvis to the left. Something's got to spin my pelvis. Like I use the basketball. The basketball can't spin itself. So am I using hands below the basketball? Am I using one hand? Am I using the other? Am I using both? In this case, I'd be using both. With the right hip, same muscles or different muscles? Different. Good. Because my right hip is externally rotated. Same contraction or different contraction?
Same.
Same. Very good. Does that make sense?
Can you say that one more time?
Absolutely. When I'm spinning the basketball, notice how my hands have to move differently. Same spin, but different motion. So we're saying is when I have left transverse pelvic girdle rotation, my left hip is going to have internal rotation and my right hip is going to have external rotation. Do we see that part? Okay. Good. So nothing's trying to spin me, so I have to use concentrics to make it happen. Left hip, I'm going to use internal rotators concentrically. Right hip, I'm going to use external rotators concentrically. And it's the same logic. The same muscles that sped me up can't push me to a stop. So once it comes time to put on the brakes, then I'm going to flip it and use their antagonists to become agonists. I like to think of antagonists and agonists, even though it's super confusing, as shift work. Like you have two shifts. You have like let's say we're talking about the firemen and the firewomen, and they have shift work. Like you work a 12-hour shift, and I work a 12-hour shift. They both have similar jobs. The muscle groups have similar jobs, but you may need one to do a function, and then they're off of work. Those are two functions. It's very simple.
So what is the other one? Because it. Since the verb like one slowing down.
Yes, absolutely. And we can still use our muscles, motion, and contraction, because we say the left transverse rotators, the muscles that pull to the left transversely, have to slow down right transverse motion, but they can only do it with eccentrics. Yeah. And again, that's important because that's when you're going to have damage. The damage is not going to come with me speeding up the right. If I did true thought experiment, if I did this, if I just looked to my right 300 straight times, I will have no soreness on the right transverse pulleys. I will have a lot of soreness on the left transverse pulleys. Braking, slowing down, that's when things get frayed. So we need to identify that. We need to know eccentrics. That's why I kind of developed the class the way I do, because it's one thing to just memorize what the definition is, but that's like teaching a carpenter, okay, what's this? That's a hammer. Good job. Right? What's this? That's a wrench. Awesome. What's this? That's a screwdriver. Cool. So there's no doubt you've been introduced, and it's not your fault. There's no doubt you've been introduced to isometric, eccentric, and concentric. You've been introduced to hammer, wrench, and screwdriver. But have you been taught how to use these tools? And that's what this is about. It's teaching you how to use these tools. Truly understand what they are. Okay? Bryce, any insight before I do the email trackers?
Yeah, I feel like regardless of this. Yeah, it's like your initial thought, and there's no external force, should be concentric, but then like braking is slowing down. You need to switch to eccentric with the antagonist finger antagonist.
Absolutely. And those are going to be key words, guys. Like I'm going to give you, I've always said I'm going to provide you with all the information you need to answer the question. Like it would be no different if you were in algebra class and to solve for X, you have to have enough information to solve for X. I mean, you can't have A plus B is equal to C without having two variables. You can either be given those variables or figure out those variables. So I have to give you enough information to solve for that last one. Okay. All right. So this was emailed to me. And again, I don't write very well. I talk. Hopefully talk okay, but I explain things a lot better verbally. But writing, I think the part that was missing in this question was that in the lecture, we emphasize that you have to be somewhere in the middle. If your windshield wiper is going to go from the left to the right, it's got to pass through the middle. Does that make sense? So that's where B lives. We don't, I'm limited to finding these exercises, and I can't do this. Never could. So we have to have that inference that there's going to be a middle part where the legs are going to be parallel with gravity. Does that make sense? So I think that's what was missed. So I'm going to be going from A to B, and then from B to C. C to B, B to A. Does that make sense? So we've done this one before, but it's good practice. Why don't I give you a couple minutes to kind of practice this one again? Remember, pelvic girdle rotation is great to discuss, but when it comes to muscles, the pelvic girdle doesn't have assigned muscles that will always be the same every time, like our elbows and our wrists, because different things can spin the basketball. I can move the basketball by palming it and spinning it, and that's what's happening here. Your trunk is taking the basketball and doing things with it, your trunk muscles. So we have to bring it back to trunk motion. Trunk muscles influence trunk motion. So even though we can see the pelvis spinning, we got to bring it back to the trunk. I thought about this, Grace. Tell me if I'm missing something. Under this condition where the pelvic girdle is moving because of trunk, those will always be in opposition. But what I can't say is that trunk and pelvis will always be in opposition, like, because when I'm standing, I can rotate my pelvis to the right and I can rotate my trunk to the right because my upper body's not fixed. But when your upper extremity is fixed, like he's not going to break the bar to spin his trunk on the pelvis. When your upper extremity is fixed and you're moving the pelvis because of the trunk, those things will always be in opposition. So in other words, a cheat code might be concentric. You may see concentric to have right transverse pelvic girdle rotation. Write that down and say, ooh, pelvic girdle spin and trunk spin are different. So if it's concentric to spin the pelvis to the right, it must be concentric to spin the trunk to the left. You see what I did there? Because I can't spin both in the same way. He would have to rip the bar off and then he'd fall down. They have to be in opposition. Maybe that could be a cheat code. Thought about that the other day when I couldn't fall asleep. Go. We're going to do a full range of motion. So let's go A to B. Who did it how? B to C. Who did it how? C to B. Coming back the other way. C to B. And then B to A. Agonists and contractions. Some of you might feel more comfortable starting with motion. You know, it's a given. We've been doing this for a long time. Some of you in this example may want to start with agonists. So find what works for you. Find what works for you. All right, let's do A to B, and then I'll give you more time, because in other words, maybe doing A to B verbally with me might unlock you being able to figure out the rest. So I'm going to just do A to B and then give you some more time. I'm going to walk you down how I see it, but then I'll show you different variations, and you can kind of pick what works well for you. There is an external force trying to influence my motion here. Gravity is trying to spin my pelvis to my left, but in doing so, it's trying to spin my trunk to my right. It's trying to make my sternum look more at my right hip. Does that make sense? What I say is, well, muscles are influencing motion against an external force, and if gravity is trying to spin my trunk to the right, I don't need muscles that are also trying to spin my trunk to the right. Because I know if that happened, I would literally throw my feet down at the ground. So I need muscles that are trying to pull my trunk to the left. That's hard to see, but it's no different. I think I tried to use this example in class. Same muscles. Speaking of micro tears,